Welcome to the next talk with the vending machine into the cloud. We have always similar topics here at CCC, but from other points of view. And the topic of electronic payment systems gives quite a lot of things to tell, and we had many talks about charging stations, about Mensa, payment cards, etc. Jans Streib is our speaker. He studies and he will tell us about electronic payment systems. Applause for Janis. Everyone who's studying in a university or working in a big company probably knows this. There are vending machines, and if you're hungry or thirsty, you can get a snack, which is more or less healthy, and pay this one with your student card or employee card. These systems, you also see them in the canteen, in the cafeteria, Mensa, and you can charge or top up these cards at the terminals like this. Sometimes there are also status terminals where you can see how much money is still on the card and what maybe the last transactions. The architecture of these systems usually looks something like this. We have our vending machine. It's also called vending machine controller, and this one communicates over MDB. It's a serial protocol with the vending reader. This one does the actual payment, and to do this it communicates with a backend via HTTPS, where the transactions are being done with a cloud-based system. Usually a payment transaction looks more or less like this. You hold your card at the machine, at the reader. It gets some information about the customer. You see, if you can also get things like date of birth, which might be important for alcoholic drinks. Then the user chooses his product, the price is being looked up, and then the actual vending process takes place.
How did
I come to this topic? I should build an integration for washing machines. It's this device you see with the red field and the two-line display in the left lower corner. But as a hacker, if you have an unknown device with Ethernet connector, then you usually do a port scan first. And there was my first surprise. I saw a VNC server. It's a real VNC, and if we have a look in an exploit database, then we find several exploits which might match this version. I tried it. Yeah, it works. Interesting. We have a Windows CE here. There's a full stack explorer. We can watch what the software is doing. The software is obviously called CS Core. Yeah. So we have for our system we have this image. There are obviously two databases on this reader: a static DB for static configurations, a work database where temporary data are saved, I assume, and these databases have it seems somehow encrypted, these databases. They cannot be opened with normal database browsers. So I became more curious We have also added the VNC here.
Weiter beschäftigt als ausschließlich mit dem Vending Reader, weder mit dem Kartensystem, was dahinter verwendet wird, also was meistens dann
I didn't really look at the card system, etc. I just looked at the reader.
Ich habe also begonnen, eine
So I began to make a rough analysis.
Eigentlich auch erstmal offensichtlich spannend,
would be interesting to know what happens on this RDPS channel.
Einfaches
HTTPS channel, sorry. So we can do man-in-the-middle gateway, we log our requests, we forward the data to the backend server, just to have a look what requirements we have. It's worth starting Wireshark once, and everyone who sees it in detail sees that this is a RV2 client, and we see the list of supported ciphers of cryptographic methods which can be used. If you look a bit closer at them, we also see that these are a bit antique, not the newest ones. Among them, I've found LV240 export MD5. Hope I translated that correctly. I didn't see that in the wild before. So we have a little problem for the proxy because not that many implementations still support SSL-v2 and RC4 and 3DES. And I didn't really want to compile things myself, so I had a look how to make it more simple, and the solution was Java 8. Indeed, if you use Java 8 long enough, if you abuse it long enough, it still supports SSL v2, hello, and RC4 triple DES. So I used my own proxy and I tried it.
Actually, I only wanted to check whether the handshake works.
My laptop dient als Proxy.
You see my laptop working as a proxy. And bang, that's our request. That was unexpected, because I haven't actually set the certificate on the system yet. So apparently there's no certificate verification here. Cool, less work. Nice leak and nice bug here. Let's look at the API a little. As you've seen in the video, there are two API endpoints. There's a heartbeat endpoint, which is used for pretty much everything that's connected to the configuration. For example, it provides the static DB for the configuration and is updated in regular intervals and at the start of the vending machine. That's an XML API, that's a request. It sends a little bit of metadata to the server. It also sends a SHA hash of the static DB. So if there's no static DB, it just sends an empty checksum. So I looked at the request a little. Then I saw that there was no real authentication. So the only thing that differs between different vending readers is the platform ID. And it kind of looked similar to me. It's kind of looked familiar to me. So it's, yeah, nice. It shows on boot, so we can just see the ID on boot and can request the static DB. Well, they're still encrypted, but maybe we can use them anyway. Next API, or let's see the overview first. We see how the static DB is provisioned. We see that we can intercept the heartbeat without any modification of the card reader. The next API endpoint is the API endpoint to interact with end-user accounts. There's some different types. Vend, which sells something, negative vend for return deposit or revalue that you can use to top up the card at some machine.
Und da ist tatsächlich eine Authentifikation drin.
There's some actual authentication in there. It's read from the static DB.
Und ist tatsächlich pro Gerät verschieden.
And is different from each device.
Interaktion mit dem Kontoverlauf, so kann man zum Beispiel darüber
also there's some interaction about the
wird es auch
account history.
Auch der Kontoverlauf angelegt darüber. Allerdings über eine
It can also be created via separate request.
normale Zahlung erfolgt,
So if there's
kein Eintrag in der Kontohistorie.
if there's a normal
Das passiert in einem separaten
transaction, it doesn't actually register in the account history.
Zahlungen zu tun haben, wie sich später
It's done in a separate request, so it doesn't even have to have anything to do with the actual
also sprich, da werden
actual transaction. So this is done via some CSV data.
Mit den Informationen, die wir nun haben, also
With this information,
Mittelangriff auch die
via the man in the middle,
haben können wir nun einfach mit meinem Laptop
we can just
Revalue ausführen. Man sieht
do a revalue request from our laptop.
100 Euro mehr auf dem Konto.
And now we have 100 euros more on my account. And even without doing anything as a user. So we can just get the wallet ID and use the device to do an API request. Nice, convenient.
Hier sieht man einmal einen Auszug aus dem
Here you see part of the administration interface, which the administrators usually see.
Das ist jetzt aus.
This is from another point of time. It's not the one that I just showed.
Unten in der Mitte, ganz unten
In
links,
the
sehen wir den
lower left,
Kontostand. Das sind hier
and
722.
we see our account balance, 722 something, and we say the account history.
Und es wurde irgendwie ein Betrag von 2000 Euro gebucht.
There was, you see a booking about about 2,000 euro. This is an interesting example where you see that there's not actually, yeah,
Arbitrare Buchungen einfach.
the bookings can be arbitrary. They don't really have something to do with the actual bookings.
Wenn man versteht,
It would be interesting to see how this databases works, because at the moment it's only possible to start attacks when we usually had a
gegen die API
when we knew a secret, and
Zugang zu einem solchen Vending Reader.
it's only possible with the man in the middle at the moment. It would be interesting to have the databases.
Quasi diese
To do this,
tiefer analysieren.
we need to analyze the software more deeply.
Beliebigen Reverse Engineer Tool
So
anschauen.
you can use a reverse engineering tool, but there you have a bit the problem that it's a exotic kind of executable format. It's Windows C for ARM, and there are not that many debuggers for it, but IDA can do it. But first I could only do a static analysis. I could not watch
wie das funktioniert.
actual data encrypting, decrypting, just
praktisches Tool, das nennt sich FindCrypt.
seeing the static binary. There's a nice tool which helps to find traces of encryption algorithms. It's called FindCrypt. It looks, for example, for certain constants which are used for certain algorithms. In this case, he found an S box, and if you see where these values are used, we can find out where the actual encryption is happening.
Dazu ein kurzer Disclaimer.
Just a short disclaimer, even if AES is quite simple, and it would be easy to build it, it would be a bad idea to use it in production code. It's just a hint. AES is in principle relatively simple. It's in principle only a key. From the key we derive several keys and apply it in several rounds using XOR on our data to be encrypted. And we shift the key, etc. And in the last round we leave out one of these steps, and in the end we have a block of 128 bits encrypted data. So now we found out our encryption function. It looks somehow like AES. It looks like these transformations and the key. And now we can monkey patch it, so to try to extract the key. In the software, it's a function which can lock things, and so we can just write the key down to the log files. It also looks really nice. You see in the last line the extracted key, but somehow this key did not really work. No matter which AES implementation or variant I tried, I could not find anything useful from these databases.
At this point I gave up, basically. I will not find out how this encryption works. But then I talked to an admin of this system, and he talked about having a decryption tool that can just decrypt all of the things.
And
then I listened up and I heard, I thought maybe all these devices use the same keys. So this decryption tool can be debugged and analyzed a lot easier because it's x86. There's lots of tools for this. So let's look at the key expansion first. So this derives many keys from this 256-bit key. And then I looked at the expansion. We'll see a video of Ida where I looked at the variable where the expanded key is set. And that looks at how this variable is filled. And we see it's filled a bit.
Jetzt fängt er wieder von vorne an.
Oh, and now it starts from the beginning. Weird.
Eine Weile so, bis er fertig ist. Und dann steht am Ende.
This goes on for a while.
Ein paar irgendwas, ein paar
until some data appears, and then many zeros are there. So the key expansion isn't really the usual one. We just get a key from another key and lots of zeros. If we put this into the graphic we had before, then the process becomes a lot simpler, and it looks like this at the end. So it's basically an XOR encryption in the end that was just mixed a little bit at the end. So With this knowledge, we can use.
Dass dort relativ viele Null-Padding-Blöcke drin sind. Das heißt, wir suchen uns eine dieser Null-Padding-Blöcke.
We can use this to get the extra material that gets us to the keys. So
uns frei Haus eine Datenbank besorgen.
So let's get a database from the API. And we can decrypt it and open it. So we get the config and everything for free. So we don't have to debug the system to get our authentication data. Convenient.
Also gut.
So
das ist so ziemlich alles kaputt, was ich mir angeschaut habe.
Everything's broken that we've looked at.
Also ja. Dachte ich wäre fertig. Ich gehe.
I guess I was done and show it to the vendor.
Probier die doch mal aus.
And then they came to me and said, "We got a new version."
Funktionieren.
And someone got me a flash drive. Just plug it in, it will work. So I was thinking, wait, how do the update work?
Rückseite einen USB-Port.
Oh. Apparently these devices do have USB ports. I looked at it for a while and found out you can put an XML file on the flash drive. And if you look a while in IDA, you'll find a parser that has lots of commands like copy file or execute file. And the CMD files aren't even signed.
Dieser Datei wird nicht wirklich überprüft.
So the identity of this file isn't really checked. So I could build some small CMD file, put it on a USB drive, and plugged it into the vending reader.
Und wenn wir den USB-Stick wieder anschließen.
And we can put the USB drive back into the laptop. And we copied some useful data. So now we get the databases and all the secrets. And we can also execute arbitrary code. Really convenient.
Spannender wird es dann noch, wenn man sieht, wie die Vorversion aussieht.
Becomes even more interesting when having at the previous version.
Erkennt man, da ist mit der USB-Port vorne dran. Hat man wohl bei der alten
in an old version, the USB port is located on the front, but this version was hanging around for many years at our university, and it uses more or less the same software. It's not that a good sign. Yeah, I still have some time, so I can show you something more, how to analyze, how I did the analysis. And the analysis helped. It really helped that the core exe writes extensive logs. It also contains function names, etc., which really helped to analyze, because you can search for the strings in the binary, and so we know, yeah, we could identify the functions quite easily. This is how such a parser looks like when such a function is being found. Excuse me, yeah, there. Now I have a little problem by reverse engineering it, because at monkey patching for extracting the key, I found out that the software does not really like to do that. It somehow strikes back. So somehow this binary is checking itself. It seems to be some CRC, because we see here CRC in it. Okay, CRC is just more like getting bit errors, not for a yeah, not for a secure cryptographically secure check. So we can also patch it quite easily because we just say CRC, it always says, yeah, it's okay. Or we just compute the new CRC checksum of our binary and just permutate the binary as long until it fits again. Or even more simple, if we just put the real file at the real place, it just works because the path is hard-coded.
Ja.
Ja.
Gut.
Very well.
Das wäre soweit bei mir.
That's it from my side.
Wir haben nur noch etwas Fragen für Q&A.
We have a lot of time for Q&A. I made a, yeah, this is a short recap of the vulnerabilities, and I'm listening to your questions.
Ja, vielen herzlichen Dank, Jannis, für diesen
Thank you very much for this interesting and fun talk. So we've got lots of time for questions. Just come to the microphones. So if you have any questions, how to hack your vending machines or other topics, please come to the mics. Don't be shy.
Bitte schön, du hast das Wort.
Was denkst du, wie man das am besten nutzen könnte?
How could you use this the best way to get free products?
Also wirklich gratis einzukaufen.
Well, to really get free products, shop for free, we can imagine different attack scenarios. For instance, you see which users there are in the system, you brute force some IDs, and you can use some one-cent transactions. Nobody cares about that, and you add all this difference to your account. So nobody will notice it.
Ansonsten gibt es auch verschiedene Varianten, das zu verschleiern. Es kann natürlich immer sein,
there are other ways to obfuscate it. It's usually not a good idea if money just appears in the entire system. So.
Second question. Hi.
Erstmal vielen Dank für den Talk.
Thank you very much for your talk.
Du hast jetzt ja praktisch viel mit Man in the Middle gemacht, das heißt...
You did a lot with Man in the Middle attacks
in einem deiner Slides.
On the network.
Hast es rausgelassen,
There's Nmap stuff. So I'm interested in how did the transport of the data work? Did you test whether the data of the card
bloß eine ID übertragen? Ich habe den Anfang des Talks nicht ganz
happens? So could you exfiltrate some ID of the card reader, or could you do more than that?
Also sprich, da kommt nur
the card reader is connected as a USB keyboard, so there only appears a part that you can set in your settings. For instance, only the ID or some lost transactions, etc. So there's not a lot to do on the card by itself because most of it is done via the cloud. It only uses the ID of the card, which you can set up in the card reader.
But you haven't tested like how the data of the cards works, how the data of the card is used. So how is the data transferred there?
Alles klar, danke.
I didn't observe such things, so no.
Internet oder aus dem Zelt? Sieht so aus, als wären alle Fragen abschließend beantwortet worden.
Looks like all questions have been answered. Thank you very much, Janis, for your amazing talk. Thank you for listening to the translation stream. We were Pharma Firma and Advan. If you have any feedback regarding the translation, you can find us